Okay, so we have looked at the case of Cournot quantity competition and collusion. We are now ready to empirically examine whether the firms are actually competing. To do this, let's consider a general first-order condition of firms that nests these scenarios as special cases. The P on the left-hand side is the price level. The P prime is the derivative of the inverse demand function with respect to the aggregate output Q. The right-hand side MC is the marginal cost. The parameter of interest is theta, called conduct parameter, which captures the level of competition. For example, if theta is equal to 1, then this corresponds to collusion scheme. If theta is 0, then it corresponds to the case of perfect competition. You can easily see that the price is equal to marginal cost if theta is 0. If theta is 1 over n, then it corresponds to the case of Cournot competition. As you can see, the level of competition is decreasing in theta. Okay, so let's see how to estimate the conduct parameter in an empirical application. We consider a case of coffee where we have data on the roasted coffee and input prices. Recall that we saw how to estimate the demand for roasted coffee using input prices as a supply shifter. Today, we will see how to estimate the conduct parameter using the demand parameter estimate as given. They found that the Cournot model of competition describes the roasted coffee market well. Let's review the data they have. So they have the price and the quantity of roasted coffee and some demand characteristics, which include the price of substitute, income, and seasonal dummy. They also have input prices such as the price of coffee beans and the wage rate for the food sector. They normalize all the demand side variables by the consumer price index or CPI to adjust for inflation. The demand is given in a linear form. Now, the marginal cost is specified as a function of input prices, which are also normalized by CPI. Given the linear demand function and the marginal cost function, the firm's profit maximization condition gives the supply equation given at the very bottom. We are interested in the conduct parameter theta in the supply equation. Note here that the aggregate output Q is endogenous, since price and quantity are jointly determined by the demand and supply interaction, which is what we saw last week. In order to estimate the supply equation with the endogenous output Q, we need an instrument that has something to do with the output, but has nothing to do with the unobserved production costs. What would be the candidate for such instrument? The demand characteristics are a good candidate for such instrument if you believe that income per capita or the price of substitute has nothing to do with unobserved production cost. Now, the question here is how to estimate theta. Note that we can estimate theta if we have alpha 1, which is demand slope parameter, and also if we solve the endogeneity of aggregate output Q in the supply equation. So we estimate the theta in 2 steps. First, we estimate the demand slope parameter alpha 1 using the input prices as supply shifter, as we saw in the previous lecture. Second, we estimate the supply equation given in the previous slide using the price of substitute and income as instrument for the output. This step estimates minus theta over alpha 1, and so we need to multiply the coefficient estimate by minus alpha 1 to get an estimate for theta. So here is a demand coefficient estimate alpha 1 and the conduct parameter estimate from Bettendorf and Verboven 1999. The conduct parameter is estimated to be around 0.06, which is pretty small, but statistically significantly different from 0. The estimation results are consistent with the model of Cournot competition in that the conduct parameter estimate is small but positive. The estimate implies the average markup of about 15%. Now, so far, we have assumed that the marginal cost of production is independent of the output, but nobody said that the marginal cost is constant. And so what if the marginal cost is increasing in output? For example, let's consider a quadratic marginal cost function where the marginal cost is given by the original marginal cost function we have considered plus a linear function of the output. Given this specification of the marginal cost, we can show that the coefficient on the output becomes beta 3 minus theta divided by alpha 1. Now, what this means is that we now cannot separately estimate the conduct parameter theta from the marginal cost parameter beta 3 by our current approach. Now, one way to separately estimate the conduct parameter from the marginal cost parameter beta 3 is to exploit demand rotation. Suppose that the demand is specified as the one shown on the slide, where we add P times Y in the original demand specification. What it means is that the slope of the demand curve changes as the income changes. In other words, the demand becomes elastic or inelastic as income per capita increases. Given the demand specification, the supply equation can now be written as the constant part of the marginal cost plus the rest. We see that the demand rotation creates additional variation in the supply equation, which allows us to separately estimate theta from beta 3. Now, so far, we have used input prices as instruments in the estimation of demand. The question is this always a valid approach? In other words, what if the majority of the coffee beans is used for the production of the roasted coffee, and the price of coffee beans is affected by the demand for roasted coffee? Now, this creates an endogeneity problem, since the unobserved demand is now correlated with the input price. And so we cannot use input price as an instrument when the downstream market is large relative to upstream market. Now let's take a look at Genesov and Moulin 1998 again, that avoided using input price to estimate the demand for refined sugar. The sugar is an important input in fruit canning, which makes it complementary to flute. The demand for sugar increases in May and lasts until September. Now, here is what they have in the data. They observe the price and the quantity of refined sugar. They have seasonal dummy and also two candidate instruments. One is the price of raw sugar. The other one is the Cuban imports. They did not use input price as an instrument in the analysis because the US consumption of sugar is too large to be exogenous. That is, the demand for refined sugar in the US could have an effect on the price of raw sugar. Therefore, they decided to use Q-band imports as an instrument instead. Just to remind you of the two demand specifications, here is the linear and log linear demand specifications they looked at. And here is the estimation result. The conduct parameter is estimated to be around 0.1 and statistically significantly different from 0. Now, their estimate of conduct parameter corresponds to the conduct of a static 10-firm symmetric Cournot oligopoly. But there are only 6 firms operating in the industry on average. Now, one way to interpret the estimation result here is that the industry pricing was constrained by the threat of entry and foreign imports. So the firms were facing the level of competition above the realized level of the competition observed in the data.